Right, now we'll discuss about ionic strength. It is a very small topic but very important, has appeared in December 2017 CSIR for 4 marks based on this concept of ionic strength. Right, so I'll just give you the formula for ionic strength and we'll solve few questions based on ionic strength. What is ionic strength? It is a measure of electrical intensity due to the presence of ions in the solution. Okay, it's a measure of electrical intensity. Now, how it is given? It is given by the formula I is equals to 1 by 2 m1 z1 square plus m2 z2 square. Whereas here m1 and m2 are molalities and z1 and z2 are valencies of the various ions present in the solution. Right. So this is the basic formula which you have to remember, because based on this formula many questions do appear in the exam. Right. Now calculate the ionic strength of 0.15 molar KCl solution. Okay. Now the question, I mean the difficulty will increase from first to second to third question. It's not like difficulty, but there's a difference in the three questions. We'll try to solve each of them. Right. So 0.15 molar KCl solution. Now what is the molality of the each ion given? That is potassium K plus is 0.15 and chloride minus is also 0.15. Now I will denote it as M plus and M minus, okay, for K plus and Cl minus. And what is the Z value? That is valencies of potassium and chlorine are 1 and 1, right? K plus and Cl minus. So these values, once we know, we have to just substitute in the formula. I is equals to 1 by 2 m1 z1 square plus m2 z2 square. So m1 is 0.15 for both and z are 1. On simplifying, you will get your answer. Very simple. Next question, 0.25 molar K2SO4 solution. K2SO4, it will be dissociated into 2K plus SO4 minus 2. Now M plus you have to write for each ion. Okay, actually M plus is 0.25 given. That is molality is 0.25 given for K2SO4, but we can know from the equation that there are 2 moles of potassium, 2K plus. So M plus will be 2 into 0.25, that is 0.50. And what is M minus? M minus is 0.25. Okay, now because here we have only 1 mole of sulfate but 2 moles of potassium, hence we have multiplied it. And what is the valency for potassium? It is 1, whereas for sulfate it is 2. So I'll even write the valencies. Now you substitute in the formula to get your answer. Next question is a solution which is 0.1 molar KCl and 0.2 molar in K2SO4. So what is common ion in both of them? It is potassium K, right? So here M1, how will you calculate is that M1 should be one ion, M2 should be another ion, and M3 another ion. How many ions are there? One is potassium, one is chlorine, and another one is sulfate. So you'll write 3 M values and 3 Z values. Okay, that's the reason I have given so on. It depends on number of ions, you need to write the equation. Right, so M1 will take it for potassium, that is K. So K is there here, K plus, and there it is K2SO4. So there on dissociation you will get 2K plus SO4 minus 2, that is stoichiometry is 2. So M1 will be sum of this and that is 0.1 plus 2 into 0.2. Why? Because there are 2 moles, so 2 into 0.2. So M1 will be 0.5. Next, molality of chlorine ions is M2. Okay, we'll consider chlorine as M2. So how much is the molality? 0.1. Next, molality of sulfate is M3. And what is the molality of K2SO4 given? 0.2. So sulfate will also be 0.2. Write down the valencies of all. Potassium we know 1, chlorine is 1, sulfate is 2. So substitute in the formula M1Z1 square, M2Z2 square, M3Z3 square. You'll get your I value. Okay. Closer to this kind of formula, like Debye-Huckel has given a formula for this ionic strength. A very big derivation is there for this particular thing. If you need it, tell me, I'll make a video, or else I can even mail if someone needs the derivation. But frankly speaking, if you know this formula, this is more than sufficient for your CSIR purposes. For other purpose, you can go through the derivation, but for exam point of view, this is sufficient. And this is very, very, very important. So they will not give Debye-Huckel limiting law. Instead, they will give DHLL. So it's important that you should also know this DHLL is nothing but Debye-Huckel limiting law. So what is the law? log gamma plus or minus is equals to minus 0.509 z plus z minus I power 1 by 2. Okay, this value is a constant value. Sometimes we write it as capital A. Okay, capital A is here minus 0.509. Now this negative value indicates that the mean ionic activity is less than unity. Okay, the law has come because the activity value is not equals to the molality concentration. Because there is some activity, the law has come, and that activity is less than unity. The limiting law equation is valid for dilute solutions only, because at high concentration the value exceeds unity. Okay, now this particular law is applicable only for very dilute solutions, but not the uh, concentration solutions, because the activity will be the this mean ionic activity should not exceed unity for this particular law to be applicable. So this particular formula very important for the entrance point of view, right? Thank you.